Hello everyone, welcome to Module 5 of our Software Design and Development course. In previous modules, you learned to write code and design software. Now, we go deep into backend engineering, the engine behind every modern application. Today, we will cover advanced object-oriented programming, data structures, and algorithms, working with SQL and NoSQL databases, building RESTful APIs, authentication and authorization, performance optimization, and back-end best practices. By the end, you will think like a professional back-end engineer. Here is our roadmap for today. Advanced OOP concepts like encapsulation, inheritance, polymorphism, and abstraction. Core data structures and algorithms with big O analysis. Working with SQL and NoSQL databases. Designing and building RESTful APIs. Authentication and authorization mechanisms. Performance optimization techniques, back-end best practices used in real-world systems. We will also do a mini project building a secure REST API from scratch. Modules 1 through 4 gave you programming fundamentals, OOP basics, and design principles. But modern systems like accounting platforms, ERP systems, or an LMS need much more. They must handle large data sets, enforce complex business logic, ensure security and scale under real-world demand. This module transforms you from a programmer into a back-end engineer, someone who builds the invisible, powerful foundation that powers everything users see and interact with. You already know basics of OOP. Now let's go further. The four pillars remain critical are encapsulation, protect internal state, inheritance, reuse code through hierarchies, polymorphism, unify interface, different implementations, abstraction, hide complexity. But advanced OOP adds more. Design patterns like factory, singulation, and strategy. Composition over inheritance, more flexible than deep class trees. Interface-based programming, programmed to contract, not concrete classes. Why does this matter? It builds flexible systems that evolve with changing requirements, essential for enterprise software. Good back-end engineers know how to handle data efficiently. Common data structures are arrays, lists, stacks, queues, hash tables, dictionaries, search instead of trees and graphs for hierarchical or connected data. Key algorithms, searching, linear versus binary, sorting, quick sort and merge sort, recursion and iteration. We measure efficiency with big O notation. Example, using a hash table instead of a list reduces search from 0n to 0, 1. Good algorithms turn slow systems into high-performance solutions. Every backend needs a database. You have two main choices: SQL, relational, MySQL, Postgre SQL. Structured schema, strong consistency. It is best for financial systems, ERP, any data with clear relationship. While NoSQL is non-rational, example, MongoDB and Redis, they have flexible schema, document or key value storage. They are best for real-time apps, large-scale systems, rapidly changing data. A well-managed database is the backbone of every reliable application. APIs are the bridge between front end and back end. A RESTful API uses HTTP methods, get to retrieve data, post to create data, and put or patch to update data, delete to remove data. Core design principles are stateless communication, clear logical endpoint structures like API users or API invoices, JSON-based data exchange. APIs enable front-end and back-end communication and integration with external systems. They are essential for modern modular applications. Security is not optional, it is a core requirement. Two key concepts are authentication, which is verifying who you are before you log in, while authorization is what you are allowed to do, that is permissions. Common techniques are JWT, JSON Web Tokens, stateless and scalable, while OAuth, login to Google, Facebook, etc. are session-based authentication. Role-based access control. For admin, you give full access, while regular users have limited access. Best practice is always hash password with be secret. Always use HTTPs, never hardcode secrets. Optimize system scale and optimize system spell under pressure. Key techniques are caching with Redis or memcached for huge speed gains. Database indexing for finding data without scaling entire tables. Load balancing to distribute traffic across servers. Asynchronous processing for queues on background tasks. Code optimization, efficient algorithm, and clean logic. Example, catching frequently accessed data, reduce database load, and speed up response time dramatically. Performance optimization improves user experience and reduces infrastructure costs. Professional back-end engineering is about reliability, security, and maintainability. Always write clean, modular, and reusable code. Use environment variables for configuration. Implement proper error handling. Follow RESTful conventions and write unit and integration tests. Use Git for version control. Document APIs with Swagger/Open API. And avoid hard coding sensitive data. Avoid writing monolithic, unstructured code, and avoid ignoring testing and validation. These habits separate junior developers from professionals. Let's apply everything to your mini project. Create a backend server using Node.js or the Django. Connect to a database, i.e. Postgre SQL or MongoDB. Implement full CRUD API endpoint and add JWT authentication. Test all endpoints using Postman. This hands-on project prepares you for full-stack development in later modules. You will gain practical experience in API design, database integration, and security implementation. Quick checklists for do's and don'ts in back-end development. For the do's, always validate all users' input, use secure authentication methods, optimize database queries, log errors, and monitor systems. Do not trust user input blindly and do not expose sensitive data and error messages. Always do not ignore performance issues and do not skip testing. Security and reliability start with good habits. Habits that scale with real-world systems are: design APIs before writing code, separate concerns, controllers, services, and models, use scalable database design, monitor performance and logs continuously, keep security at every layer, never an afterthought. Backend engineers build the invisible foundation that powers everything users see. In conclusion, today we cover the core of back-end development, such as advanced OOP for flexible systems, data structures and algorithms for efficiency, SQL and NoSQL databases, RESTful APIs at degrees between systems, authentication and authorization for security, performance optimization for scale, professional best practices. This knowledge is the foundation for building real-world systems like accounting software, ERP platforms, and learning management systems. In upcoming modules, we will move into testing, deployment, and full-stack implementation. Thank you and see you in the next module.